In this video we'll have a look at the design of the Pivotbolt. This bolt is for a 4-box rally car. It is part of the suspension. Since the car has been out of production for a few years now, spare parts are getting hard to come by, especially those that are specific to that model only. Because Ford used this special uniball suspension on that Focus, this bolt is not very common to come by. So instead of waiting for weeks for the new part to arrive from the other side of the world and paying a pretty good price for it, we decided to make it by ourselves. First of all, measurements needed to be taken. Since we didn't have the original spare part, all measurements were taken from the suspension using calipers. To create a valid geometry with those measurements, we looked up some pictures from the internet and created this sketch. Since it is a bolt, which is a classical turning part, all we needed to do is create this simple sketch. As you can see, it's only half of the bolt because we're going to revolve it around this axis to create this cylindrical geometry, as it is done on the lathe basically. So once the sketch was finished, as I already mentioned, we just simply used the revolve command, and then we added some chamfers. Chamfers are needed to ease the assembly, and of course we don't want anyone to hurt themselves with those sharp corners. So some chamfers on the ends and a few fillets for the inner corners, because we're unable to create the sharp inner corners due to the geometry of the turning insert. And finally a few more features. So once the 3D model was finished, it's good practice to check if everything makes sense and there are no design errors. Since we are going to create the NC code by hand, it is a good idea to create a technical drawing. That way we have all the necessary measurements on a single piece of paper and we don't have to look at them from this 3D model. It would be very inconvenient to use this, for example, measure function to measure all this geometry afterwards. Here we have the technical drawing of the bolt. As you can see, the main part of it is the cross section of the bolt. All the measurements are marked from the end of the part to ease the creation of NC code. The tolerances on this drawing are taken from the Mechanical and Metal Trades Handbook, and they are there because these surfaces are to be mated with the bearings and we cannot allow that our part doesn't fit correctly. The same goes with the surface roughness. And that was the design of the Pivotbolt.